Okay, hello, welcome to another case walkthrough. Today I'm looking at the Microsoft Excel World Championship 2023 case called Lana Banana or Lana Banana or however you want to pronounce it. And this was from 2023. I think it was the round of 128. I had a quick look earlier. It seems that on the day there was at least one player who, if I'm looking in the right place, did get solved the whole case, but the vast majority of players kind of got somewhere between kind of 500-600 seemed to be the sort of average. So a tough case on first look, and that was definitely my experience. The first time I did this without knowing anything about it in the time limit, I was definitely within that lower range rather than up near the top. Yeah, an interesting one. I've been through, looked at some of the walkthroughs that other people have done, so I'm not covering any new ground here. And I'll say a little bit about my approach as I go through. Again, really just doing this for my own learning, forcing myself to kind of really understand the questions and the cases, and the sort of learning a few skills as we go along. So thank you to Harry Gross for this case. Quite an interesting one. And yeah, let's just get straight into it. I'm going to go over to my score sheet, start the game. We got half an hour on the clock, so let's get going. So we've got all we've got is a case and a map. Our map over here is full of bananas. So what I'm going to do is I'm just going to unhide all the space around it because I like to be able to see that. And then I'm just actually going to cut these column headers and put them down here, move them out of the way because later those things might get in the way if we leave them there. And then I'm also going to grab this whole map and I'm going to name it, and we'll call that MP for map. And I'm also going to find and replace, I should have searched anything that is in there because it's just basically bananas, and replace it with a 1. So we're dealing in ones and zeros rather than bananas. Normally I'd make a copy, but I know in a real case I would, but I know that I don't need to do anything else with that. So that's absolutely fine. So we've set things up. So the first question, if Lana starts on the following cells and moves straight down without using diagonals, how many bananas will she collect? If she starts on a cell with a banana, she can grab it immediately. See, I'm going to do a data table because I wanted to kind of build this out as an approach, and I'm going to try and do this with dynamic arrays, although this isn't what I would have done the first time. So we are going to work out firstly how many goes is this person going to move. So we want to, let's import our lambdas. I'm going to take the row num of the cell reference. So there are 30, it's on the 31st row. So how many turns will we take? It's going to be 40 minus that. And then let us turn that into a sequence of turns, so we know how many turns to take. And then at each turn, what we're going to be doing is we're going to be going down. So let's get an arrow for now. So I've got an arrow from text. So we're going to go D for down. That gives us our arrow. And then I'm going to use move on map to take my starting cell, which in this case is B1. And I would move this arrow, and that would tell me where I would get to next. So one cell down from D31 is D32. But I actually want to kind of do this dynamically. So I'm going to turn this into an array. So we are going to scan through an array starting on D31 or cell B1, going through this many turns. And then our lambda is we're going to have an accumulator and a value. And basically on each turn, it's our accumulator that we will start with. And our arrow value will be whatever is in E4 each time. And that's going to give us all of the cells that we are going to go to. And then we need to work out whether they have a banana in them, but we also need to include the original cell. So I'm going to VStack cell B1 and this. And that's going to give me all the cells we go through. And now we need to work out whether they have a banana or not. And I'm going to go to the map. And I'm going to go over here to the right. I'm going to use my address book lambda on the map to get all the cells. And because obviously that first column, they've all just got a 1 in them. So actually we don't need that first column. So let's just drop that first column. And then let's just copy and paste those values only. So we're not using an array formula that's taking up computing power in case we need it later. And let's call this our bananas range. So these are all the cells that have bananas in them. So let's just name that range bananas. So now all we need to do is go through this array. And for each cell, we just need to know is number, I need to do it inside a lambda. So lambda for each member of the row is number, but let's use our exists lambda. That's what it's there for. So exists, the item in our bananas list, and that will return a bunch of trues and falses. So actually let's make that a minus minus. We get ones and ones and zeros, and let's just sum that array. And on the first one we get 1, and we get our answers for the others. Let's copy that over to our walkthrough case answer sheet, and we get 60 points, which is a good start. Right, now if we go to level 2, we're going to be able to leverage what we've just done into level 2. So we'll build a data table, but we'll grab our workings from level 2. We'll copy that over to level, sorry, workings from level 1. Oh, I've just copied and pasted an empty row. So let's grab that, go back here and paste that. And then our arrow is going to be whatever that is. And we've got something else going on here. So our turns are the same. We're starting there, going through each cell. And yes, so we need to say that if it goes out of bounds, what do we do? So we're going to tell it that we're going through the map MP, and we want to glide along when we go hit the edge of the map. And now our lookup should be that cell. We'll copy those over to our score sheet, and level 2 is done. So level 1 and 2 are very different to the rest of the case. Level 3 onwards involves us interacting with this map. So Lana can now move in any valid direction move. If she starts on these rows 38, these row 38 cells on the map, what is the highest number of bananas she can attain? So we're going to do this by making a copy of the map. And we're going to start at the bottom, which is because we're moving down, and we're going to actually clear out all of these values because we're going to insert a formula in there. So let's start in this cell here. We're going to say we want to take the maximum of the 3 cells below it plus whatever is in the equivalent cell in the actual map. And if we drag that to the right and also drag it to the left, and that should still work because we're not up against the edge of the map because we've got this buffer zone here. And now if we fill that all the way to the top, we see the values cascading through of how many bananas we can pick up from each starting cell moving down through the board. So now we can go to our case and we can say, in fact, let's name this range with our answers. So let's call this, use the wrong shortcut, Alt F3, let's call this map _2. It's our second map. And then here, I'm going to use my address lookup. So I'm going to look up in map _2 this cell here, and I get 1. And I can actually fill this all the way down for level 4 as well. Fill that all the way down, and I should be able to grab, oh, don't want all of that. So let's just use the mouse here. It's a little bit inefficient. Trying to avoid my mouse usage. Level 3 questions there, 200 points. And then let's go to level 4, grab these answers here and go to level 4, and we've got 220. And then we're going on to level 5, where there's an extra rule that says if she is just eating a banana, then she can't pick up another one immediately. So what we have to do here is let's we can just use this map because we don't need this particular formula for any of the bonuses, so don't need to do an extra copy. So now we've got 2 options, so we need to consider a further level. So if we take a banana in this level, it means we couldn't have taken one from the previous one, so we need to consider the scores from the row below that, but that's a little bit wider. So what we're going to do is we're going to say if the equivalent cell here is a banana, then what we want to do is, I'm going to just build this one step at a time. So if there is a banana in that previous, in the actual cell, we want to take the maximum of the kind of 2 rows down plus 1 for the banana in the cell we're getting. Otherwise, we're just taking the maximum from the row below, but we're not adding anything because there's no banana in its current cell if that's the case. So let's fill that to the right. We'll also fill it to the left, but then we'll get an error here because this range was trying to search all of that and it can't go any further, so we just replace it with the 4 cells rather than the 5, and then we fill that up all the way to the top, and our numbers are going to go down because we're going to miss some bananas because of our stomach ache that we can't pick up 2 in a row. And now we can actually just use the same formula as before because we're using the same map. So we get 5 on that bonus, sorry, on the bonus, on the example. So those answers look fairly good to me, but famous last words. There we go. No, that's all good. Okay, and then we're going to go on to the bonuses. So the first 2 bonuses are just about assessing the grid itself. So the first one, how many 2x2 grids contain at least 3 bananas on the map? So if we go to, we can do this on the original map. So let's just create a sequence of, I'm going to say 39 because I know there's 40 rows, but in that last one, we're not actually looking at 2x2 rows on the map. So, and I'll do the same going the other way. And then all I want to say is I want to sum these 4 cells here. And then I want to know if that is greater than or equal to 3. And because I want 1s and 0s, we'll wrap that in brackets and put a minus minus. And then what we will do is we will go all the way to the end of this range, fill that right, and then I will do something similar here, fill down, and then what I'm going to do is grab this range here, and the sum down here tells me that that is 37. Then how many distinct pairs of neighboring bananas are there? So what I'm going to do is I'm going to go through, we've got a list. Let's get rid of this working here. Just taking up space. Let's clear that out. So we know all the cells that do have bananas in. So what I want to do is go through each of those cells and look at all the cells around it, see how many pairs it has. So how many kind of pairs it is part of. So I'm going to do an indirect onto this cell reference. I'm then going to wrap that inside an offset, and my offset will be -1, -1, and then 3 and 3 to give me basically the 9 cells around it. I'm then going to sum that, but I'm also going to -1 because the middle cell doesn't need to be counted again. And I'm going to move that up here, and I want to then drag that down, and that's going to tell me how many pairs there are, which gives me 408, but because each of them is counted twice, because we count it both ways, the actual answer is 204. Let's just copy those over to the score sheet just to get those working in the background while we go on to the final, most difficult question, which is, for this question, Lana can also move right as well as down, diagonal left, down, diagonal right, down. So he also has the stomach ache from level 5. Starting from any shell she likes, what's the most she can collect? So let's, again, we'll just use the same map, but if it was in real life, I'd make a copy in a case just in case I get anything wrong. So this time we've got this added thing where we can actually move to the right. So each of our options, we need to decide, we need to include extra options. So for this cell here, the next 2 moves onwards, these are not all the, this blue box is not all the locations we could get to with 2 moves. Because we've now got the option to move right, we actually need to include some more cells. So we also need to include these 3 cells here, because we could go down, left, and then right, down, and then right, and down, right, and then right again. And we also need to include this cell here because we could take 2 steps to the right. And then similarly for the kind of 1 step, we could also go to the right here. So we add that in as well. So we'll then fill that to the right, and we start getting numbers going up. Because we can go to the right, we'll just drag it to the left, and then we'll have to just change this referencing error to these 4 cells here, and that should all be correct. And then we'll drag that up all the way to the top, and then we want to find the maximum number. We can kind of eyeball it, that it's, then it kind of intuitively makes sense. The biggest, since you can kind of all move in this direction and to the right, the best place is to start in the very top left, and the answer is therefore 40. And we'll go to our score sheet and just give that a second, and right enough, it comes through true. 1250 points out of 1250, so we can stop solving. So 13 minutes 17 seconds, even with a little bit of explanation. It's one of those where once you know the approach, it's, you know, that's obviously understand, you know, someone did do it in the real thing in that time. I didn't get near that on my first time through, but having obviously learned something about the case, you then know how to approach it. So yeah, an interesting one. This kind of where do we look here? Map 2. This kind of iterative approach where you kind of work backwards through adding is something that comes up in a lot of map cases I've seen, something I've come across. So that's, yeah, but this was a nice challenge in starting to introduce those extra rules and having to expand the search area. So I did like that as a case. So yeah, thanks very much for watching. If you found that helpful, great. If you didn't, doesn't matter, because I found it helpful to do this for myself. So thanks for watching.